Hey YouTube, what's up, it's Link. Welcome back to another episode of Coding Session. And I know it's been a little over 2 weeks, but I'm in the home stretch of getting or graduating with my Bachelor's of Science in Computer Science degree. I will be the first person blood related in my family to graduate with an engineering degree. So it's a big accomplishment, and I want to finish strong. So busy with that. And I'm also in the process of becoming a software developer for Publix. It's been a long process of waiting patiently for the applications to open, communicating back and forth with the IT recruiter, communicating with the staffing department for the information systems department, speaking to the manager of staffing, and also speaking with the actual developers who already work there. So it's been a long process. It's still going on, but I do expect and see great things. But here we are back in coding session. My problem of the week for 2 weeks, which is integer to Roman. So if you don't solve the problem Leetcode sends you in the Leetcode Weekly Digest, they're going to keep sending you the problem until you solve it, which is understandable. And the problem I had before this was Roman to integer. This is its sequel, which is integer to Roman. This is the old problem we did 2 episodes ago. I recommend if you're watching that to understand what's going on here. We've pretty much taken a string, which is a Roman numeral representation of a number, and we kind of examine it character by character to figure out if this Roman numeral was before this one or this Roman numeral was after that one, to go ahead and determine the number. And this is done with a for each or enhanced for loop. This time we're going to use recursion. Now, so yeah, we're going to use recursion for this one. If you go down in the discussion section, there's going to be many solutions to this, but I'm going to write the solution first and then go over it with you guys in kind of like a notepad, because there's something specific to this recursion that I have to kind of explain, not just going line by line in the code. So this is going to be a recursive function, so we need our base case. So if num is less than or equal to 0, we simply just want to return blank. I'm going to paste these two in to save time, but before we had a dictionary with each Roman numeral and it identifying its value. This time we have a string and integer value that kind of sync up with each other. But you're going to notice that we have special cases of Roman numerals such as 4 or 9. Again, I'm going to explain why we have these, and you can see it in the discussions section when using a recursive solution like this. And we're just going to do our int I, because we are still going to have a loop here, s.length. There's one. 4, and since we already have our I, we just do semicolon. I is greater than 0. I minus minus. We're going to start from the top, 1,000, all the way down to 1. And if num is greater than or equal to value of I, we're going to break out of this for loop, and we're going to start our return to build our string our Roman numeral representation of the integer we want to convert, or we're bringing in, and instead of taking string Roman numeral representation of the value and turning it into an integer, we're taking in the integer and turning it into that Roman numeral representation. So return si. Remember the array string and the array the integer. The string array and the integer array, s and value, sync up with each other. So 1, 4, 5, 900, which is the CM, etc. So return, start building our string, si plus int to Roman the num minus value of I. Let's go ahead and run this code, see if we pass the most basic test cases. And we do. So I'm going to bring this text pad over here and show you why this works. and why we have these kind of specific Roman numeral combinations like 4 and 9. So let's start with just the basic, which is 7. And 7 is pretty much VII. So starting with 7, if we're going all the way down from 1,000 to 1, we're eventually going to reach the case of 7 is greater than or equal to 5 in our if statement within the for loop. We will then put V, and then we pass on 2, which is 7 minus 5 when we're doing our recursion right here. I don't know if you can see my cursor. Right here. So the second iteration, or the second part of the recursion, if 2 is greater than 1, then I. Now it's VI, because we're going from 1,000 all the way down to 1. So we'll eventually reach this because going through 5 and 4, they aren't greater. 2 is not greater than those, so it's going to keep going all the way to 1. Now we have VI, and then we pass in 1. 2 minus 1 is 1. So 1 is greater than or equals to 1. That is true. Then VII, which is the Roman numeral representation of 7, we pass a 0 in. The base case will result, and recursion will stop. Now let's go over 4, which is the first example of this weird combination of the... I am recording, right? That would be embarrassing if I wasn't recording. Okay, yeah, so 4, which is the first combination of that weird Roman numeral combination on our string array. Of course, we also have to account for that in our integer array of value. So 4 is greater than 1, that's true. We return I. Now we have I. We pass 4 minus 1, which is equal to 3. Now, since we do... Okay, I'm sorry. This right here is... Imagine this was not in here. 4... IV and 4 were missing from the string array and the integer array of value. So 4 is greater than or equal to 1, that's I. Now I, we pass in 3, which is 4 minus 1. Now 3 is greater than or equals to 1, doesn't hit 4, remember that. It goes from 5, then to 1, then I. And now we have II. But this is not possible. That's not the Roman numeral representation of 4. We already broke pretty much our function here, our method here. So with 4, with IV, or the Roman numeral representation of 4 in the string array, and having the value, the integer value of 4 in our integer array of value, if 4 is greater than or equal to 4, simply return IV, which is the Roman numeral representation of 4. Now 4, we pass in 0, base case results, recursion stops. And this goes the same for 9. Which one is this? Oh my god, this is embarrassing. At 9, 10. Is that 40? No, it's 50. Hold up. That's right, L is 50, so that is 40, and then this is 50. 40 is kind of similar to, obviously, the 4. And that just keeps on going. 400, because C is 500, so XC is also the same case, and etc., etc. So that's the reason why we need these specific Roman numeral combinations to get our function, our recursive function, in this case, our recursive solution to work. And you can kind of go ahead in the the discussion section, and see why recursive solutions such as this need those combinations. I did forget to mention, but if you identified the syntax, we are using C#. Let us submit our code. And there we go. Runtime 92 ms and faster than 75.62% of C# submissions, which is pretty good. Didn't expect that. So that is integer to Roman, the sequel, bigger brother to Roman to integer. Thank you guys for watching, and if you have any comments, feedback, or you want me to explain something further, leave your comment down below and I'll try my best. Thank you guys for watching, and have a nice day.